Let's take a look now at solving linear inequalities. Now remember that linear inequalities are very similar to equations, except for the fact that now we see a greater than sign or a less than sign. So in these types of situations, we're still trying to isolate the variable, but the answer now is not just going to be one solution. The answer is now going to be a whole span of solutions where x is going to be larger than a value or smaller than a value. So notice that the only difference is going to occur in solving linear inequalities if we're dividing or multiplying both sides by a negative number. So we're going to have 8 different situations that could show up. Assume that x is our variable. And what if we had the a was a number? Well, let's say that I had an answer of x is less than a. Let's just say that a is equal to 5. Then this might look like x is less than 5. The easiest way to visualize this is by graphing it first. If we were to put a on our number line, then x is less than a would mean everything below a or to the left of a. Now notice that I put a hole on the graph as well because of the fact that a is not included. And therefore, since negative infinity is on the left side of the equal sign, and positive infinity is on the right side of the equal sign, then this answer for the interval notation would be negative infinity to a. Now one more thing to recognize is that when there's no equal sign in the inequality, we're going to put a parentheses on the a. Notice how this will be different if we had x is less than or equal to a. Notice the only difference now is that we have a filled in dot at a to show that a is a possible answer. So the answer will still be all the values from negative infinity up to a, except we can now include a as our answer. And that's why we put a bracket on a. If we have x is greater than a, then obviously we're going to start at a and shade everything above a. X is greater than the value of a, so it's everything to the right of a on a number line. Well, now notice that the lowest value here on the number line is a, while this expands all the way to infinity. So we start at a on the left and expand to infinity on the right, which is a little different than if we had x is greater than or equal to a, because now we should recognize that a is a possible answer, which is why we fill in that dot. And now we put a bracket on a instead of a parentheses. Now these are all the standard, I'd say, shapes in inequality form and interval notation for a particular inequality. But sometimes we may have something referred to as a compound inequality. This is saying a is less than our answer, but our answer is less than b. In other words, x is somewhere in between a and b, which is why we shade everything in between the values of a and b. So since a is the lowest and b is the highest, we're now going to put a parentheses on both a and b. But now what if we ended up having an equal sign on b? Notice the only difference is that now we can shade in b with a dot, which now means that this one would be everything from a to b again, except there's a parentheses on a and a bracket on b. It's possible that instead the equal sign happens to be on a. So this is still saying that x is everything between a and b, but it's possible for a to be an answer, which is why we now put a dot at a, but a parentheses on b. That means that now the bracket moves over to a, and the parentheses is now still going to be on b. But lastly, it's still possible that both of them have an equal sign. Notice that if x is between a and b inclusively, where a and b are also allowed, then that just means that there's a dot on both, and therefore we can put brackets on both of our inequalities. So this middle column of interval notation is the most common way to demonstrate or to write all the solutions to an equation. So let's take a look at an example here, like this inequality. We're going to solve this very similarly to how we solved an equation. we're still going to distribute that negative 4 to get negative 4y plus 4. While on the left side, we still have y plus 14. Now, I will say the one difference here is that we do want to always try to get the variables on the left. It doesn't matter if you do move it to the other side, but it's always best to keep the variable on the left side because it's easier to visualize the answers on a number line. So let's subtract y from both sides, and that's going to get rid of the y on the right. We can now subtract 4 from both sides, which moves that over to the right, giving me negative 5y is less than 10. Now the last thing to do in order to solve for y is divide by negative 5. And notice that if I do so, I'm left with y is greater than negative 2. Notice that I had to change the direction of the inequality sign because I divided by a negative number. And therefore, as an interval, since it's going to be every answer above negative 2, my answer is going to start at negative 2 and go to infinity. Let's take a look at another example here. What if we were to look at this one? Same general idea. We can distribute the 3 on the right side, and now we get 3a minus 4 is less than or equal to 3a plus 15. Now notice at this point, we can subtract 3a from both sides, but notice what's peculiar about this is that there's a 3a on both sides. So by subtracting it, now I get a statement that says negative 4 is less than or equal to 15. Now notice all the variables canceled. So we can't actually describe just a particular region on a number line anymore because there's no variable. However, negative 4 is less than 15, and therefore this is a true statement. And because this statement is always true, that means the solution set is all real numbers, which would imply on a number line that I could shade every single number. And therefore what we say as an interval is negative infinity to infinity. So solving inequalities is very similar to solving equations, except we have to realize that our answer is going to be an interval. And secondly, if you divide or multiply by a negative number, you have to change the direction of the inequality sign.